Hello, AP Chem. This is Mrs. Chana bringing you your first lesson, Atomic Structure and Properties is Unit 1. And Section 1.1, Moles and Molar Mass, is what you're going to hear about tonight. Formula and molecular mass, the mole and Avogadro's number are the three things you'll learn about, and hopefully this will be review. Let's get started. First of all, some definitions. Formula and molecular mass are the sum of the atomic masses of the atoms in a chemical formula. So why two different names? Formula mass is referring to the basic unit in a network solid, and it's the mass of one of these basic units. Remember, ionic compounds exist in networks in a lattice structure. So NaCl, for example, sodium chloride, is a network where there are many sodium and many chloride ions stuck together, but they're in a 1-to-1 ratio. We don't have molecules of NaCl. Instead, we refer to NaCl as a formula unit within the network solid. And so then we find the mass of one formula unit when we find its mass. Molecular mass is used to refer to molecules that exist independently. These are covalent compounds. So they are molecular mass is the mass of one molecule. Now, I've called this molar mass. It's more general, but on the AP exam, they could ask you one or the other specifically, and they're both done the same way. So how are they done? Let's find the formula mass of magnesium hydroxide, Mg parentheses OH parentheses 2. You got to know the formula. In order to do this, you use the periodic table, find out the atomic masses off of those elements, multiply and add together. 1 magnesium, 2 oxygens, 2 hydrogens, all add up to 58.33 atomic mass units. So that would be the formula mass of one formula unit of magnesium hydroxide. Avogadro's number. Its symbol is N for number and a subscript A for Avogadro's number. This is a big number. This many quarters would cover the surface of the Earth to a 2-meter depth. This many grains of sand would cover the state of Texas to a depth of 15 meters. 6.022 times 10 to the 23rd. What? Per mole. That's the unit, per mole. Anything's per mole. Donuts per mole. Grains of sand per mole. Quarters per mole. So the unit is given as mole to the -1. So you might want to get used to seeing the units in this way. We need this number because it's easier to work within the macroscopic world than it is in the microscopic world. You cannot put one water molecule into a beaker, but you can put a mole of water in a beaker, and that would be 18.02 grams of water. So Na provides a connection between the number of moles in a pure sample of matter and the number of particles, or the number of units in that sample. So as you remember, the mole is one of the most important units in all of chemistry. The mass of 1 mole of any element is equal to its atomic mass on the periodic table in grams. 1 carbon atom has a mass of 12 AMUs, and 1 mole of carbon atoms has a mass of 12 grams. 1 mole of neon atoms would be 6.02 times 10 to the 23 neon atoms, and that would be 20.18 grams. Now, in AP, we know the Avogadro's number to 4 significant figures, so we can write atomic masses or molar masses to 4 significant figures. If we're going to use this in a calculation, we get to keep 4 sig figs. 1 mole of chloride ions, that would be 6.022 times 10 to the 23 chloride ions, is 35.45 grams. If 1 atomic mass unit equals 1 gram, would we be in the situation we're in? Does 1 atomic mass unit equal 1 gram? Hopefully you said no, because 1 atomic mass unit is equal to 1.6 times 10 to the -24 grams. 1.0 moles of H atoms will have a mass of what? 1.0 grams. 6.022 times 10 to the 23rd hydrogen atoms multiplied times 1.66 times 10 to the -24 grams for every hydrogen atoms is what gets us to 1 gram. The mole is the fundamental unit for counting particles on the macroscopic level, and this definition is important for the AP Chem learning objective. It allows us to draw quantitative connections between macroscopic experiments at the atomic level, chemical processes. All right, molar mass of CO2. I know you could probably do this in your sleep. What would be the mass of a mole of CO2? Well, we figure out its molecular weight, and we get 44.01 atomic mass units per molecule. And we know that 1 mole of CO2 molecules is this many molecules, 6.022 times 10 to the 23rd CO2 molecules. What's its mass? The molar mass is 44.01 grams. Hopefully that's a review for you. So you convert this to grams. How many moles of NaCl are there in 48 grams of NaCl? Well, you'll need to set it up so the units cancel out to give you the units you want in your answer. Did you set it up like this? The unit you want to get into goes on the top, so we want moles of NaCl on the top, and 58.44 grams NaCl on the bottom. 48 grams is what we start with. 0.82 is what we calculated. Even though there's 4 digits here, there's only 2 here, so we're going to make sure our number is rounded to 2. Did the units cancel? Sure they did. Try this one yourself now. How many grams of C2H6 are there in 18.7 moles of C2H6? Pause this, give it a try, and then restart. We're going to need to set it up so that we start with the number given, 18.7 moles, and we're going to make a conversion factor to get us from moles into grams. The unit you want to get into goes on the top. The unit you want to cancel out goes on the bottom. So in the next step, we get 562 grams of C2H6. I want to evaluate this answer. 1, 2, 3 digits. 1, 2, 3 was given. I went and got 4 digits for the molar mass off the periodic table, so my significant figures could carry through. Next example. Converting from grams into molecules. How many water molecules are contained within a 56-gram pure sample of water? I know you can do this. This is going to take 2 steps. Pause the video, pause the lesson, and try it yourself. And we're back. The first thing we do is write down the value that was given in the problem, 56 grams. Set up a conversion factor. We're going to convert out of grams into moles because we have the molar mass of water easily calculated. Sometimes I call that the side calculation. And then we're going to use Avogadro's number to get us into molecules of water. Why is Avogadro's molecules this time? Because that's the unit water comes in. It comes in molecules. Is that the unit that was asked for in the question? Sure it was. So the units all cancel. We're going to do 56 times 6.022 times 10 to the 23rd divided by 18.02, and we'll get 19.24 molecules. Let's convert from grams to atoms. You can do this one. How many hydrogen atoms are contained within a 56-gram pure sample of water? Pause the video and give it a try. Okay, we're back. To find out how many atoms of hydrogen are present, well, we just need to take it one step further. Start with the 56 grams of water we're given. Convert that into moles using this conversion factor. 1 mole over 18.02 grams. Second conversion factor, 6.022 times 10 to the 23rd molecules of water per mole. And one more, 2 atoms of hydrogen in every 1 molecule of water, for a grand total of 3.7 times 10 to the 24 atoms of hydrogen. Now you probably had way more digits than that in your calculator, but you had to round it to just 2 digits because they gave you 2 sig figures when you started the problem. Okay, that's it. That's the lesson. Lesson 1, out of the way. Good luck with the practice. Move on to lesson 2. Thanks for listening.